Hello everyone. So today we are learning refraction. Refraction is the phenomenon of bending of light when it travels from optically rarer to optically denser medium. So you can imagine this is an interface which is separating two optically different medium. One is thin and is optically dense. For example, this is air and this is glass. If this is a ray of light, this is the normal. The ray get refracted. Okay, that means it moves towards the normal. This is called the angle of incidence and this is the angle of refraction. This phenomenon is called refraction. The bending of light while traveling from optically rarer to optically denser medium is called refraction. In rarer medium, in rarer medium, in rarer medium, the ray moves away from the normal. From the normal. While in denser medium, the ray moves close to the normal. Close to the normal. What does this mean? It means that this is the interface. By interface I mean the boundary separating the two medium. This is the normal. If this medium, this is medium 1, this is medium 2. If the medium 1 is optically dense compared to 2, let's say the ray is traveling like this, 1 is denser than 2, optically denser than 2, then what will you see? That the ray, that means 2 is rarer than 1. So in this case, if this is the ray how it is traveling, it is quite far away from the normal. As it enters the denser medium, it will move towards the normal. In this would be the angle of incidence, this is the angle of refraction. Understand? This is in case this happens in case of refraction. Let us see laws of refractions. Laws of refraction. First one, the incident ray the reflected ray, the refracted ray, and the normal all lie on the same plane. This is one. Now for the second one, so I hope you can understand that if I what I mean is this is the interface x, y, which is separating two medium. This is medium 2, this is medium 1. Let's say this is the normal. So if this is the incident ray and this is the refracted ray, okay, so the whole thing, all these three rays will be lying on a single plane. That means this is going to be a single plane. Understand? Let's come to the second law. What is the second law? It states that the ratio of sine of angle of incidence, sine of angle of incidence to the sine of angle of refraction is a constant. This constant is called refractive index. This constant is called refractive index. It can be absolute or it can be relative. We will see in a separate video. Refractive index, that is if this is the refraction happening at a particular interface, according to the second law, sin I by sine of r equals to constant, equals to n. We denote this constant by n, where n is called the refractive index. This law is also known as known as Snell's law. Fine. So this is just a little bit introduction on the phenomena of refraction. Now one question can arise: what is the cause of refraction? Why does it happen? Cause of refraction? Refraction is due to refraction takes place due to variation in speed of light while traveling from one medium to the other. To the another. Okay. For example, the speed of light in air is 3 into 10 to the power 8 meter per second, and in glass it would be 2 into 10 to the power 8 meter per second. We will see this when we do refractive index. So this is the little bit of introduction on refraction. Now we will see a practical demonstration on this. How does it actually feel like? So I am using a physics engine here, so simulator. Let's see how we can set up the environment. So I will first make a block. Imagine this is a glass. I will give its appearance as a, I'll give appearance material as a glass. So this is glass now. Now what I'm going to do, I'm going to choose a laser source or a light source. So if I use a light source, let me alter a little bit. Right now I'm using a green color source. So let me give it a color to red, and I'm also decrease its size, fading distance to a little less. This is much small. So like this. Now we'll pass it. Now let me pass it through this one. Say, can you see refraction is taking place? This line, this is the, here is the normal, here is the normal. These two interfaces. One interface is this one, and the interface is this one. Okay, the speed of light in here, which is a air, is now 3 into 10 to the power 8 meter per second, and the speed of light here is 2 into 10 to the power 8 meter per second, as it is glass. So now what is happening is it is being constant from here to here. There is no deviation. However, again as it appears the other interface, the light undergoes a change in its velocity, and then again it follows. Notice one thing here: this ray and this ray is parallel only. So but the distance by which it moves away from its original path is called the lateral shift. We will be deriving a relation on that also. So now let's see what happens if I increase the refractive index of the material. Let's say increase the refractive index of the material. Observe what happened. Let me increase the refractive index. You see the bending is taking more. Now here what is happening? Here reflection and refraction, and also total internal reflection taking place. You see, this is the reflection, this is refraction, and this some portion of the light is getting internally reflected within the medium. This is called total internal reflections. Not complete total, but partial internal reflection is also taking place. We will learn about total internal reflection in future videos. Okay, so let me increase it a little bit further. Now to convert this into a mirror, what will happen is refractive index becomes infinite. As it becomes infinite, then it is only reflecting surface. It's not refracting anymore. Understand? So let me bring back to around 6. Yeah, 1.5. Fine. I hope you understood it. I hope you have liked the video. If you have liked, please subscribe it, because more videos as I upload, you'll get to know easily. Thank you.